So, good evening, children, once again. Now, moving on to the next topic. We were discussing tokens in the last class, and I had already discussed keywords and identifiers. Now, we are going to go into literals. So, what are literals? Literals are the constant data items whose value never change. Like, for example, suppose your name is Alok. So, Alok is a data. It is always going to be ALOK. Okay, it is a constant, it's never going to change. Similarly, 5, 7, 13, 14, these numbers are going to be 5, 7, 13, 14 only. They're never going to change. So any data is known as a literal. Now, what are the different types of data? So as per Java, data are of so many types. You can see the list on the side screen, and I have categorized them as literals. And the broad classification is that literals are first of integer types, then floating or real types, then character types, then string types, and then boolean, and then null. So what are these? One by one I am going to discuss and tell you. First of all, integer literals. So what are integer literals? Integer literals are pure numbers without any decimal point. 5, 7, 19, 20, all such numbers come into the integer literals. Now, remember in your earlier classes, you would have studied about number systems. Number systems, if you remember, there were 4 types: binary, octal, decimal, and hexadecimal. So these 4 number systems play a specific role in computing. Okay, and each number system is designed for a specific purpose. Now, I am not going to go into details of these number systems, but just let me remind you that we had numbers in hexadecimal number system also, we had numbers in octal number system also, and decimal number system also, and binary number system also. Binary data is not considered directly in Java, so they are not taken into consideration when we are discussing integer literals. Integer literals are broadly classified as decimal integer literal, octal integer literal, and hexadecimal integer literal. So first of all, what are hexadecimal integer literals? Hexadecimal integer literals are hexadecimal numbers. Okay, if you remember, from 0 to 9, and then A, B, C, D, E, F. A was 10, B was 11, C was 12, and D was 13, and E was 14, and F was 15. So these were the hexadecimal digits. Now what comes after F? Again, many of you might be thinking. So after F, again it starts from 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 1A, 1B, 1C, 1D, 1E, 1F, then again 20, 21, 22, and so on. So all these numbers which are in hexadecimal, they are generally used for memory addressing. And if I am taking a number in hexadecimal, then it will come into the category of integer literals. So what are hexadecimal integer literals? Hexadecimal integer literals are those numbers which are without decimal point. Point number 1. Point number 2, they consist of hexadecimal digits from 0 to 9 and A to F, and they must begin with 0x. Now what is the story of 0x that I am going to discuss a bit later. Next comes octal integer literals. So in the same way, octal integers are those integers which contains like octal digits, that is from 0 to 7, and they begin with 0. Again, the 0 we are going to put up sometime later. And then finally we have decimal integer literal. Decimal integer literal is the basic number system which you follow in your mathematics, that is digits from 0 to 9. Now if you notice the chart which is given at the side, decimal integer literal example is given as 5, then octal integer literal is 0, 5, and then hexadecimal integer literal is 0x5. So what is this all about? So let me tell you. Let us consider a number 5. This 5 is in decimal category also, in octal category also, and in hexadecimal category also. So if I type 5, how will the computer understand that it is decimal 5 or octal 5 or hexadecimal 5? So to make computer understand it is hexadecimal 5, what do we do is, instead of writing only 5, we write 0x5. So whenever computer sees 0x in front of any number, it understands it is hexadecimal. When it sees 0 in front of any number, then it understands it as octal number. And when it sees that 0x or 0 is not associated or not prefixed with the number, that means it is a pure decimal number. So that is integer literals. Floating or real literals are numbers again, but with a decimal point. They are represented in two ways. One is fraction, that is your normal decimal method, the way you write decimal numbers. You can see there in the example on the screen. And second is exponent method. Now what is exponent method? Exponent method, children, generally we use it when we are writing very big numbers. Like for example, charge of an electron, minus 1.6 into 10 to the power minus 19 coulombs. Or speed of light, 3 into 10 to the power 8 meter per second. Now, if I write these numbers on the computer, it will be 3 and after that 8 zeros. So again, that becomes a problem. Okay, suppose if I want to write the charge of an electron, minus 1.6 into 10 to the power minus 19. So imagine how are we going to write this? 1.6 divided by 1 and then after 19 zeros. So to represent such big numbers, okay, what we do is we use exponent system. The whole number is divided into two parts. The first part is known as mantissa and the second part is known as exponent. Suppose if I want to write 3 into 10 to the power minus 3. So 3 is the mantissa and 10 to the power minus 3 is the exponent. So how do we write it? You can see their example. 3, the mantissa part I have written as it is, and then capital E or small e and then only the power. That is minus 3. So computer will understand it as 3 into 10 to the power minus 3. If I want to write minus 1.6 into 10 to the power minus 19, then how will I write? Minus 1.6 e minus 19. So that is how we write data in exponent form. Then comes character literals. Character literals are single characters enclosed within single quotes. Now remember, in computers we do not refer as apostrophe or inverted commas or something like that. Here we use single quotes and double quotes. So single characters enclosed within single quotes, that is character literals. Now at the end of the character literals you can see /n and /t. What are they? They are known as escape sequences. Now what are escape sequences? They are also known as non-graphic characters. There are certain keys on the keyboard which when pressed do not print anything but produce a desired effect on the screen. Such keys have representation in Java and these representations are known as escape sequences or non-graphic characters. For example, when I press A on the computer keyboard, what happens? A gets printed on the screen. But when I press tab button, does anything get printed on the screen? No. A effect is seen on the screen, that is the space bar moves ahead by 6 spaces. So Java has got representation for such kind of keys, which when pressed do not print anything. And these representations are known as escape sequences. Like /n is for enter button, that is new line. /t is for tab space. /a is for the computer bell. So that way, children, you have got escape sequences. They are also included in character literals. The whole list of character literals you are going to get in your book. Now what is string literals? String literals are one or more characters enclosed within double quotes. So that means every character literal is a string literal, but every string literal is not a character literal. So you can see there in the example, A, capital A, I have placed within double quotes. Small a, I have placed within double quotes. Even 4 is a number. But when I place it within single quotes, computer will take it as a character, and when I place it within double quotes, it will take it as a string. That means this 4 number will lose all its mathematical powers. That means if I put 4 in single quotes or double quotes and then I try to add something, the result will be very different from what you generally assume. So, if you have one or more characters enclosed within double quotes, then it is a string literal. You can see there slash and slash t are included here also. Next comes Boolean. Now, Boolean literal means Boolean data. Now, what do we understand by Boolean? Many times in our lives, we come across certain things where the answer is either yes or no. Like, for example, are you a teenager? Now, answer may be yes or no. Are you married? You can say yes or no. You cannot say, sir, I am half married.